Now let's continue here, but if I'm going to get a more complicated final, what can I do? I can make it like this. First one, I would like you to test whether sigma square and sigma y square are equal to each other, okay? I can ask you to test this. And when you test it, of course you're going to get an answer, right? Your conclusion. So if I ask you to test the variance, whether they are equal to each other or not, you may have two conclusions, right? The first conclusion is they are equal to, right? And the second possibility is they are not equal to, okay? So in this case, if you test it and figure out that actually the variance should be equal to each other, so what should you do? You should use SP squared to continue your question, okay? And if not, then you should use nx sx squared plus the sy squared divided by ny, okay? So if I'm going to get the question a little bit complicated, this is what I will do. But you don't need to worry too much about it. Sometimes people say, if question 2 follows question 1, and then if you make a mistake in question 1, then you're going to get penalty for question 2, because the answer from question 1, the answer you get from question 1 is wrong, right? So there's no way you can get question 2 right. That's wrong, because basically this is what you get from question 1, right? And if your conclusion is this, then of course you should follow this. If your conclusion is this, then you should follow that. So I will grade it based on question 1 alone, and then I will look at what's your conclusion. If your conclusion is this, then you should follow this. And if your conclusion is this and you follow this, then you are right. If your conclusion is this and follow this, of course you are right. But let us say if your conclusion is this and you follow this, of course that's wrong, right? So you don't have to be worried too much about it. I will grade from each question separately, okay? I'll give you grades from evaluation of each performance, so you don't have to worry very much about it. Anyway, let us continue to move here. So page 340, right? If you get there, what do you get? You get, there is a critical value, right? The critical value is the, this thing here, right? The critical value, right? So that's oftentimes I denote it by X star, okay? But how do you get this critical value? First, you have to make a decision on what? Significance level, right? You have to make a decision on significance level, and then you can get X star. And then you have to make a decision, right? How are you going to make a decision? You get X bar naught, right? If this one is higher than this one, you say is too big. I'm going to reject H naught, accept H1. If this is on the left-hand side, what would you do? You say, I'm going to accept H naught. Okay? Okay, we will get to examples very quick. Okay? So now let us turn to 343. Page 343. We have one case here. Okay, so the question says, Jamestown Steel Company, okay, Jamestown Steel Company, manufactures and assembles desks and other office equipment at several plants in western New York State. The weekly production of the Model A325 desk at Fredonia plant is normally distributed. So this is very important, right? Is that the population is normally distributed, okay? And then what is the mean? So the mean is mu x is equal to 200, right? And standard deviation, sigma x, is equal to 16. Recently, due to market expansion, right, so new production methods have been introduced and new employees hired. So there is a status quo, right? The status quo, the original condition is the production mean, okay, 200, and the variance is, the standard deviation is 16. So this is the original situation. But what's going on now? We hire new employees. So we got new person. This person may not be that experienced, right? So they are not as skilled as the other people. And also they got new equipment. So you don't know the function of the new equipment is equal to the old ones, okay? The one you have used. So you have a original situation, and then you have a new situation. Of course, you want to make sure that the new methods or the new employees, the performance is the same as the old ones, right? Okay, so let us continue. The vice president, right? Sometimes we call VP. Vice president, sometimes we call VP, okay? Of course, you know VIP, but VIP has nothing to do with VP. That's totally different, right? VP, vice president. VIP, very important person, okay? That's different. So the vice president of the manufacturing would like to investigate, okay, whether there has been a change or not, okay? They want to find out whether there is a change or not, okay? So to put it another way, so what does that mean? Whether there is a change. What does this mean? Whether there is a change. As a matter of fact, you put it in another way, whether they are equal to, right? If there is a change, then they are not equal to each other. So what would be the null hypothesis here? H naught. What should be H naught? It should be the new product, the new methods, whether they are equal to 200 or not. If there is a change, right? If there is a change, then it is not equal to, okay? So then the H1 mu x is not equal to, okay? So basically, whenever you do these kind of questions, you want to make sure that you are able to draw a diagram here, okay? First, you have to identify the H naught and H1, okay? And then draw a picture, okay? If what you want to test is whether they are equal to each other. So if the sample you get is too big or too small, then you say, no, they are not equal to each other, right? Okay, so basically you have to get these two things. And then, after you set up this, what's the second step? The second step is that you have to try to figure out what is the significant level, right? So what is the significant level? So let us say we use alpha equals 5%. Okay, so let us say we use alpha equal to 5%. So in this case, right, this one has to be 0.025, right? And this part, probability 0.025. And you want to test whether they are equal to 200 or not, okay? So in this case, this is what we have. Then the next step, right, okay, you want to figure out what is the statistics you have to use. Because in this case, we are dealing with mean, okay, so what is the statistics you have to use? You have to use sample mean, right? You have to use sample mean. And then you have to figure out your decision rule, right? How you're going to make a decision to say this is too big or too small. So then the next one you have to figure out what is the critical value, right? The critical value in this case, because this is 0.025, right? So how much it should be here? 0.475. So can anyone tell me, in terms of z distribution, okay, in terms of z distribution, because later on I'm going to talk about, there are more information here. N is equal to 50. Because it's talking about weekly production, right? Weekly production, and the sample has 50 weeks. Okay? In this case, the sample has 50 weeks. What kind of distribution should we use? 50 weeks. 50 is greater than 30, right? So it should be normal distribution, okay? And then, so can anyone tell me what should be this value, z, in terms of standard normal? What should be the value here? Check the table. You look at me, you don't get any answer, right? What should be here? 1.96. I believe it's 1.96. Can anyone check the table for me? Can anyone check the table for me to make sure that it's 1.96? So then in this case, we're going to get two critical values. One is on the right-hand side, the other on the left-hand side. Okay? Anyone got the number? 1.96, okay? But remember, here it will be 1.96. Here it will be negative 1.96, okay? So then let us try to figure out what's the critical value on the right-hand side and the critical value on the left-hand side, okay? Let us take a break. Let us take a break. Hypothesis test. So in this case, we first have to find out what's the critical value, because that's how we're going to make a decision. That's the basis, okay? Without this, we don't know what's going on there. And since we find out that when the significant level is 5%, okay, then we get the corresponding z here is 1.96. And so we need to figure out what's this value and what's this value. And according to interval estimate, okay, we get the value there should be 200 plus and minus, right? 1 point. Let me give you the formula first. It should be x bar, right? Plus minus z times alpha over 2, right? And sigma x squared divided by n, right? That is if it is a normal distribution. If it is a t distribution, then there will be t and n minus 1, right? Alpha over 2. And here it is sx squared divided by which number? Divided by n, right? Divided by n. Okay. So because it's normal distribution, so we use this formula. It's 200 plus minus 1.96 times, okay? And there are 50 weeks, okay? They have 50 weeks of data, right? So 50. And sigma x squared should be 256, right? Okay. Can anyone give me this number here? How much is that? Anyone give me this number? No one get a calculator? $256 divided by 50 and square root of it. 2.26, right? Okay, and so what is these two? When they multiply to each other, what's that? .43, okay? So you get 204.43 and 195.57, right? So the right-hand side critical value is 204.43, right? and the left-hand side is 19557. And the question tells us, okay, according to the book, x bar 0 is equal to 243.4. Is that right? Okay. So in this case, what should we do? We should accept h naught or reject h naught. Because this value is actually within this area, right? So what should you do? You should take action A naught, okay? Because here you're gonna take action A1 because it's too small. Here you should take action A naught. The same thing, here you should take action A naught. And then here you should take action A1, okay? And so let us say in this case, you use alpha is equal to 5%. You fail to reject H1, okay? You fail to reject H1 and you accept H naught. And suppose you use alpha is equal to 1%. So that's 0.01, right? In this case, the critical value is going to move further right and further left. So what does that mean? You will have the same kind of decision, right? Because this value is actually within this area. And if you decrease the significant level, that means you increase the confidence interval. So the two critical values are going to move further out. So in this case, you will make the same decision. But now let us say that alpha be equal to 10%. Okay, now we change the rule, right? We change the significant level. We say now alpha is equal to 10%. Okay, will you make the same decision? We don't know. Let us try. If alpha is equal to 10%, the corresponding z should be 1.64, okay? So now it should be 1.64, right? So can anyone give me this value here? 1.64 times 2.26. How much should it be? How much is it? 3.71, okay? So in this case, when the left-hand side and the right-hand side critical value is, okay, 203.71, right? And here is 196.29, right? Because the value we have is 203.4, okay? So it is still within the confidence interval. So we will make the same decision. We accept H naught and reject H1. But let us say it is 203.8. Okay, let us say it's 203.8. What would you do now? When the significant level is 5%, we accept H naught, reject H1, right? But when it is significant level is 10% and the x bar 0 is this, what will we do? We will reject H naught and accept H1, okay? So whether you're gonna accept H naught or H1 depends on two decisions, two conditions. One is the significant level, right? One is the significant level. And the other is, of course, this value, right? Of course, this value, okay? This value. Okay, then let us stick to the original question, and we want to calculate beta, okay? We want to calculate beta. Let me draw the diagram again. And let us stick to the 10% case, okay? So now the alpha is equal to 10%, okay? And we know the critical value here is 203.4, 0.71, right? And here it is 196.29. And this is 200. And we know in this region we're going to take A1, right? In this region we're going to take A1. And in this region we're going to take A0. A0, okay? And alpha is equal to 10%. Let us say now we know the null hypothesis. Now we figure out actually this number should be 202. Okay? After we get the new methods of production, we get new employees, actually the production level increases, okay, 202. Then when we made this kind of decision, we know alpha is equal to 10%, right? What is beta? Okay, the same thing here. It is 203.71, right? And here it is 202. Because now we say which one is true? This one is true. So, okay, so you have to stick with this number. And here 196.29. Okay? So now we have to figure out which one is which one, right? So this one is alpha over 2, and this one is 1 minus alpha in this region, right? And here the same thing, alpha. What is this area? This area is actually, can anyone tell me what should be this area? And this we say area A and area B. This area is H0 is true, and you say H0, you take it, right? You accept H0. But this one is H0 is not true, but you take A0, right? So this is beta, okay? This is beta. And what is A plus B? A plus B should be 1 minus beta, okay? So now let me give you the formula to calculate beta, okay? What is beta here? So beta actually is this area, right? So let me mark this as 1. Roman number 1, okay? This area plus this area. So if you can figure out the probability of 1 and probability of 2, then you get beta, right? So beta is the probability of you take action A0, but H1 is true, right? And this probability is equal to P, okay? So first you have to get this area, right? So it's from 202, in between 202 and 203.71, right? Okay, so it is probability, actually we can say is this. X, right, is less than or equal to, X bar, okay? 203.71 and 196.29, right? So this area is beta, right? This area is beta. So basically, if you just follow this formula, you should be able to get it. I don't want to get to the calculation part, okay? If you have this, you should be able to get it. Let us move to the next example, okay? Let us look at next example. P-value, okay? So on page 347 of page 347, we say sometimes, because when you make a decision, as we just shown, right? This is very important, significant level. If you have different significant level, you can go from accept H0 to reject H0, or the other way around. So in this case, it is very important you mention this. But sometimes we don't want to talk about this. We want to talk about the p-value. And what is p-value? The probability that this will happen, okay? So from here, you don't have significant level anymore. What do you have? You have x bar naught. So you try to calculate x bar naught. And for the value above x bar naught, what is that? That is p, the probability. So in this case, the smaller p is, the higher the probability you will reject h naught and accept h1, right? So if this one is smaller, then the probability you will accept h1 is higher and reject h naught is also higher, because accept h1 is the same thing as reject h naught. So the smaller this one is, your decision will be closer to accept h1. The larger this is, then the decision will be closer to take h naught, okay? Okay, let us try to move on to question page 348, okay? Page 348, we have a different case. Okay, so I just hope that when in the final, English is not your question, okay? So you want to read a book, okay, to make sure that you understand what's going on. So in this case, the Thompson Discount Appliance Store. What means appliance? What means appliance? Appliance sometimes we call white goods. Okay, what means white goods? You know, before we get different colors, oftentimes, what's the color of a refrigerator? Is white. The color of oven, the color of microwave, washing machine, it is all white. So these products are called white goods, okay? Appliance. But this is a discount appliance store, right? So just like Dollars, right? Dollars and Taisuko, all these kind of stores. The credit manager wants to find whether the mean monthly unpaid balance is more than 400, okay? So now, this is very important because these words will determine what is H naught and what is H1, right? What's your concern? You are concerned that whether the mean monthly unpaid balance is more than 400 or not, okay? So probably the original condition is 400, right? And if it is more than 400, then that's not good because unpaid balance, right? You want consumers to pay the product, but sometimes they don't pay it. So you worry that some people don't pay it. If the unpaid balance is small, then that's not too bad. But if the unpaid balance is high, then you will get into trouble, right? So in this case, okay, you assume first you are concerned that whether this will be more than 400, right? So this one is your, okay, this one is your alternative hypothesis, H1. And then the null hypothesis is less than or equal to 400, right? Okay, so this is the first step. If you get this step wrong, then you probably will wrong later on, right? So you want to get this right, okay? Read the sentences very carefully, okay? Okay, then the level of significance is 5%, okay? Alpha is equal to 0.05, okay? And a random check of 172 unpaid balance, okay? So N is equal to 172. So when you read a question, you want to translate that information into the symbols or numbers, okay, and figure out what's going on there. So this gives you a hint. What should be the, what is the distribution that you should use? You should use normal distribution, right? Because this is a large number, right? 172. And this is a significant level. And this tells you, you worry that whether the number is too big or not. If that is too big, then you're gonna say, I'm gonna take H1 and reject H0, okay? The same thing here. You will get a critical value, right? Okay. And what else? It doesn't say anything about standard. Oh yeah, standard deviation is there. So the X bar naught is 407, right? And the standard deviation Sx is equal to 38. Okay. So based on this information, we want to tell ourselves, ask ourselves, whether this one is too big or not. We want to figure out whether this number is too big or not. So first we have to figure out what is the critical value there. Okay. So this is 5%, right? But you want to be careful. This is one-side test, okay? One-side test. So if this is 5%, what does that mean? Here should be 0.45, right? So what should be the corresponding z there? The corresponding z should be equal to 1.64, okay? It should be 1.64. Okay, so let us get the critical value first. So the critical value should be 400 plus 1.64 times, because you have that many samples, right? 172. And here it is 38 squared, okay? Can anyone tell me what's this number here? Use your calculator. What is that number there? 1.49? 1.49. And what about this number? $2.44. Okay, so that's 402.44. So this number here should be 402.44, right? But what's the sample? The sample is 407, right? So what would you do? You're gonna reject H0, okay, and take H1. Because within this area, you're gonna say H0 is true. But beyond that, you would say no, H1 is true. And 407 is greater than 402, and it is much bigger, right? Much bigger, okay? Any questions? Let us move on to the next example here. Okay, so page 351. Page 351 tells you under what kind of condition that you should use t-distribution. So the first thing is the sample size is small, or the population variance is unknown. Okay, population variance is unknown. But usually we just determine that by the numbers, okay? Basically, if it is big, we use, if the sample size is large, then we use normal distribution. On the other hand, if it is small, then we use t-distribution. And of course, another one is that when the population variance is unknown, we may also choose to use t-distribution. But in this case, do we know the population variance? We don't, right? We don't know the population variance. Yes, we do. How much is here? Yeah, 38 squared. Okay, no problem. So what should be the number? This is 38 multiplied by 38. 2.91? 0? Okay, so then what's this number? 1.94 times 4.476? 76, okay, 4.76. But still, this number, okay, there's something wrong here, okay? We have to, I mean, this is 38 squared, so that's 32 multiplied by 32. And so this number should be 4.76. But if you look at this, the critical value, even if it is 4.76, right? What kind of decision you will make? Because this one is still larger than this one, right? So still we accept H1, reject H0, okay? So we get back to the question here, okay? So this is a larger sample size, so we use normal distribution. So let us look at the next example, okay? The next example is an insurance company, okay? This insurance company reports that the mean cost to process a claim is $60, okay? So we know the mean cost is equal to $60, okay? And industry comparisons show that this amount to be larger than most other companies, okay? So they instituted cost-cutting measures. Okay, so the original cost for them is $60, right? It is $60, but somehow they find out that this cost is too high. Of course, when you find out that the cost is too high, what should you do? You need to cut costs, right? When you figure out the cost is too high, of course, you will take actions to cut your cost. And then, after cutting the cost, after you take actions, of course, you want to try to figure out whether you have reduced the cost or not, right? So in this case, what should be your alternative hypothesis? You want to figure out whether the actions are effective or not, okay? Whether the action can indeed reduce the cost. So the alternative hypothesis should be 60, right? I mean less than 60, because you will try to figure out whether you have done something effective or not, right? And then the null hypothesis is that, well, still the same thing, right? You haven't done anything. I mean, you have done something, but the actions are not effective, okay? Okay, so let us continue. So they institute cost-cutting measures. To evaluate the effect of the cost-cutting measures, McFarland selected a random sample of 26 recent claims. Okay? What does that mean? They take 26 claims. So they take 26 samples. The sample size is equal to 26. So what kind of distribution should you use? Z or T? T distribution, right? Degrees of freedom? Degrees of freedom? 25, right? Degrees of freedom, 25. Okay. And so now they find out that the mean cost is 57. Okay, the mean cost, that's X bar, right? They do a sample. I mean, they calculate the mean from the sample. They get 57, and the SX, the standard deviation, is equal to 10. And we want to use a significant level. Okay, alpha is equal to 0.01. Okay. So basically, we can throw all this information into a diagram. Okay, so you want to make sure you are able to do this. If you are not able to do this, you're going to get into trouble. That's what I'm going to promise you. Okay, you want to be able to draw all these things, and then because the question will further ask you about beta, okay? Okay, let us try. So we have we are comparing this, right? 60. Okay, 60 is here. And we know we want to make sure that indeed the actions are effective. It can indeed cut the cost. Okay? So this is a left tail test. Okay? We want to make sure that indeed the cost is cut. And so we need to figure out what's the critical value here. Okay, what's the critical value here? And so then, because now it is T distribution, right? It is T distribution, so you need to figure out, okay, this will be 60, okay? Because basically, when in this case, you are still assuming, okay, H naught is true, right? Under these circumstances. And so you need to figure out this one, and it should be, let me give you the formula first. It should be X bar naught minus, right? In this case, it's minus. T, degrees of freedom is n minus 1. And in this case, the significant level is 0.01, so it should be 0.005, right? Times Sx squared divided by n, okay, divided by n. The degrees of freedom is n minus 1, but this number is n, okay, this number is n. So this is 60, right? Minus. Can anyone tell me what's this number? It should be in the book, right? What's this number? You want to be able to check the table, right? And this one will be Sx squared, that will be 100, right? 100 divided by 26. What's this number here? Does it say that here? Okay. The book shows you how to check the table, right? Look at page 353. Okay, page 353. So that's 2.4855, right? 2.485. Can anyone tell me what's this number? Get a calculator. So it's 60 minus 2.485 times, should be close to 4. Close to 1.86596. Okay, thank you. Okay, then what's the total number there? $4.86? Okay, good. 87. Okay, so then you've got, it is 55.13, right? So the critical value here should be equal to 55.13. Okay, so then, because the value you get is 57, this is the value you get. But this is the critical value there. So 57 is somewhere around here, right? So what would you do? You're going to accept H naught or reject H naught. You're going to accept H naught because it's above this critical value, right? So what does that mean? That means the company has not done enough to cut the cost. They should take more action to cut the cost because their cost is still high. Okay? Because if they indeed cut the cost, the value should be below this number. Okay. Okay. And now let us assume. Okay. Let us assume. Because the next step, I want to tell you how to calculate beta. Okay. The next step, I want to tell you how to calculate beta. So let us say indeed the H1, okay, the mu x is equal to 57, right? So let us say indeed you figure out the new cost is actually 57. So in this case, how to calculate beta? Okay, how to calculate beta? So we know in this area it is 1 minus alpha, right? And this area is alpha, right? And now, hold on. So can you still get a sound there? Anyway, when did it happen? No idea. Okay, let's move on. We want to calculate the beta there. Okay, so we know this is 55.13. Okay, and now we say H1, the mu is actually 57, right? So this is 57. If the value is below this, you take A1, right? If the value is above this, you take A0, okay? So in this case, what is this value and beyond if H1 is true? If H1 is true, this one should be 1 minus beta, right? And this one should be beta, okay? And so how to calculate beta? In this case, beta will be equal to probability of x bar, okay? That is greater than or equal to 55.13, okay? So basically, you calculate, you get a z, right? And calculate, you got this area and then plus. So that is P, okay? X bar between 57 and 55.13, but this area only covers this area, right? And plus 0.5, right? So that's beta. So in this case, you know alpha is very small, right? In this case, alpha is only, where is it? Alpha is only equal to 1%, right? What happened to beta? How much is it? It is at least 50%. So the type 2 error is actually very high. Okay, the probability of type 2 error is actually very high. So sometimes you just look at this number, but you have to look at this number too, right? I mean, this number is going to show you that even though the type 1 error is very small, but type 2 error is very big. Oh, there's a great risk there, okay? What time is it now? We have some more time, so let us move on. Let us get to question 3, the question on 355, page 355. Okay, the same thing here. The mean length of a small counterbalance bar is 43 millimeter, okay? And then the mean, where is the mean? The mean is 43, right? So mu x is equal to 43. And how many bars do you get? You get a random sample of 12 bars, okay? You have 12 bars. So that means the sample size is equal to 12, right? And okay, so in this case, you have to calculate here. So let us get rid of this. So for this question, it is a little bit tedious. You have to calculate x bar 0 yourself, okay? You have to calculate it. And then also you have to calculate Sx yourself, the sample mean and sample standard deviation. And the alpha, okay, the significance level is equal to 0.02, okay? So you should be able to figure that out. And because there are only 12 samples, right? only 12 samples. So what is the degrees of freedom? The degrees of freedom is equal to 11, right? Degrees of freedom. And let us see what's going on here. So at line 3, okay, at line 3, he asked the engineering department to investigate. What's our concern? The concern is that the production supervisor is concerned that the adjustment of the machine producing the bars have changed. Okay? So the same thing, right? We are concerned it has changed. So if it has changed, that means it is not equal to, right? So we are concerned whether it is equal to the original size or not. Okay, so that's our concern. So in this case, our concern is whether it is equal to or not, whether it has changed or not. So equal to or not equal to, right? Equal to or not equal to, and the number should be 43 here. So basically, you just follow the same rule, okay? You follow the same rule, you should be able to get the answer, okay? So let us stop here and we will continue next week. Thank you.